Hello everyone. Now we'll be continuing with the theory and the next topic being the PWM pin. So PWM is one of the pin available in the Arduino. It's not available in most microcontrollers that you see around you. The normal pins that you would see in microcontrollers would be digital pin and the analog pins. And this being the third specific feature of the microcontroller being the PWM. What does this PWM stand for? It stands for pulse width modulation. Okay. So you know what is a pulse and you're going to vary the width of the pulse using this pulse width modulation pin. So the normal pulse width is like half. Okay, so the width will be on for half of the duration. It will be off for half of the duration. So that is what a normal pulse will look like. But what is pulse width modulation? Modulation means changing it accordingly. So the width of your pulse is going to be changed accordingly, which will be used in many applications. So that is what we'll be looking into this particular topic over here. So PWM stands for pulse width modulation. Okay. It is a technique used for controlling the brightness of LED. It can be used for controlling the speed of a DC motor. It can be used for controlling a servo motor, or even you must get an analog output with digital means. Okay, so if you want to do any of these, you'll be using this particular PWM pin over here. LED normally you will turn it on or turn it off. For an example, DC motor you will turn it off or you will turn it on to a particular speed. But if you want to vary the speed or vary the brightness of your particular motor and LED respectively, you will be using this particular concept of pulse width modulation. So why are you going to do that? That is what we'll be looking into. So the Arduino digital pins either give us 5 volt when turned high or 0 volt when turned low. Okay, so the Arduino digital pins, please remember the digital pins from the output you will be getting 5 volt when it is high and 0 volt when it is low. And the output is a square wave signal. So square wave only. So when it is 1, you will get a logic high of the square wave. When your output of the digital pin is 0, you will be getting the logic 0 of your particular pulse wave. That's the difference. So if you want to dim an LED, okay, so if you want to dim a particular LED, we can get the voltage between 0 to 5 volt over here. Okay, so if you want to dim the particular LED, we cannot get a voltage between 0 to 5 volt with the normal digital pin over there. Okay, so 5 volt maximum brightness, 0 means off, LED is off from the digital, but we can change the on and off time of the particular signal. So you can change the timing of the on and off. That is the only thing that you can be doing with the digital pin. So that is the concern. Okay, when it is an application like an alarm or something like that, that is more than sufficient. But some applications, very rare applications, you will want the brightness of your LED to vary accordingly. But that cannot be done with a normal digital pin. Okay. So if we will change the on and off time fast enough, then the brightness of the LED will be changed. That is the concept that we are going to be using here. If we will be able to change the on and off time fast enough, then the brightness of the LED will be changed to here. So the on and off time will be changed fast enough so that the brightness changes can be visible to us. That is what we are going to be looking into detail. So it is a technique for getting analog results with digital mode. So you want analog results, but you do not have analog means. That is when you will be going in digital means to get the analog value. Okay, so that is what this PWM is all about. Digital control is used to create a square wave, a single switched between on and off. Okay, so digital control is used to create a pulse or a particular square wave over here. That is a signal switch that is being either on or off. This on-off pattern can simulate voltages in between the full VCC that is provided by the input, which can be 5 volt on Uno or 3.3 volt on an MK board. Okay, and it is 0 for off. Okay, by changing the portion of the time the signal spends on versus the time that the signal spends off. So the on time versus on time off time, that is the supply voltage with respect to the ground voltage. This on to off time ratio is what we are talking about over here. The duration of on time is called the pulse width. So please remember the duration of the on time is called as the pulse width over here. To get the varying analog values, you change or modulate that pulse width, thus giving the name pulse width modulation. So please remember you have a pulse over here. We call that as the particular pulse. The on time, that is the time that it is high, it is called as the pulse width. Okay, so please remember the on time alone is called as the pulse width, not the entire pulse over there. So to get the varying analog values, you are going to change the pulse width. So pulse width, you know that if there is a total 100, the pulse width will normally be 50. That is, the on time will be 50 and the off time is going to be 50%. So 50% on time, 50% off time, totally one pulse will be having 100%. So the pulse width normally being 50%, you can change the pulse width from 10%, 20, 30, 40, 50 all the way to 90. So if the pulse width is on for, that is if the on time is 90%, you know that the off time is going to be 100 minus 90, 10%. So this is just an example for you to understand. So we'll be looking into that, how it is happening. In the graphic on the next slide that you will be seeing over here, the green lines represent a regular time period. This duration of period is inverse of the PWM frequency. So you know that time is inversely proportional to frequency. So that is a basic formula. F is equal to 1 by T or T is equal to 1 by F. That is a basic formula that you'll be using. So you will be seeing the particular slide with respect to time period over here. Don't get confused that you are seeing it with respect to time over here. The pulse, normally you will be looking at with respect to frequency, but this is inverse of that particular frequency over here. In other words, with Arduino's PWM frequency at about 500 Hz, the green lines would measure 2 milliseconds each. Okay. If from your Arduino PWM frequency at 500 Hz, you will be able to measure 2 milliseconds frequency. So 1 divided by 500 is equal to 2 milliseconds. Okay. So that is what you will be getting on the particular waveform over there. A call to analog write is on a scale of 0 to 255. So if you are giving an analog write over there, the scaling value, this you would have seen in the basic LED fade in fade out example which we saw in the second unit. In the second unit we saw the LED fade in fade out concept in which we saw that the varying values were from 0 to 255. So that is what they're talking about over here. A call to the analog write is on a scale of 0 to 255 such that the analog write 255 requires a 100% duty cycle. We will look into that. What is the duty cycle? What is the duty cycle? It means on time is 100. Okay. Always on. That is on time 100 means you know that on time 100% means the pulse is always on. So it is not a pulse now actually. It is a DC signal. Okay. So 100% duty cycle means it is a DC signal and the DC signal is having a high voltage. That's all. So 255 means that is the condition. And an analog rate of 127 means 50% duty cycle, which means on time is 50% and off time is 50% or off time, for example. Other one, you know by default, 0% duty cycle means the pulse is a DC signal with a particular value of 0 always. Okay. So analog right over here is the AC signal part over here. And which are the only two DC signals available from 0 to 255? The 0th value and the 255th value over here. Okay. So this is what they are talking about in this particular pulse width modulation concept. Okay. So you see 0% duty cycle. It is a DC signal which is always off over here. Okay. And this is with respect to the green color line which is 2 milliseconds. And the 2 milliseconds is nothing but how much? 500 Hertz. So we are talking about a 500 Hertz input signal that was provided to this particular condition over here. When 500 Hertz was provided, it is now split into 2 milliseconds over here, F equal to 1 by T. But when you are having 0% duty cycle, the on time is 0, which means 0%. The off time is 100%. So 100% of the time from one green to another green, what is happening over here? The value is becoming the particular 0 here. Okay, it is always 0 here. Next, 25% duty cycle. So what does the percentage mean? I told you the percentage is the on time or the off time. Please remember the percentage always represents the particular on time of the particular pulse signal. So if it is 25% means 25% of the time it is on, remaining 100 minus 25, 75% it is off over here. 25% on, 75% off. 25% on, 75% off. So when are we going to get that? When we are giving an analog rate value of 64. So when we are giving a value of analog rate 127, we saw it in the previous slide that it is 50% duty cycle, which means that 50% of the time the pulse is on and the 50% of the time the pulse is off. So never relate the 50% to the off time. It is always 50% with respect to the on time. 100 minus that percentage value is the off time of that particular signal when it comes to duty cycle, when it comes to PWM. Okay. So this is my 50% on, 50% off. Okay. So which means that it is getting maximum time on and minimum time and equal time off over here. It is getting equal time on, equal time off over here. Look at this condition, 25% duty cycle. It is getting the signal only for this much time. Remaining time it is off. Then again it is be on over here. Then remaining time it is off. So you can understand that over here the brightness of the LED is going to be very low because it is getting the 5 volt for very less duration of time. That is the concept over here. And the remaining time it is off, but all of these happen within a fraction of seconds. Okay, so on and it is off, on and it is off. So the timing is what we are talking about in this pulse width modulation. So 50% means the LED is having its 50% of its brightness. 25% over here means though it is off for 25%, the LED will have 25% of its brightness, and that switch is so fast that you will not be able to see this switching off period over here. It will all happen in what you say less than 2 milliseconds, which you cannot see with the naked eye. Okay, so this is 2 milliseconds over here means you can see that 25% of that. You can do the small calculation over here. It is 1.5 milliseconds over here, and this is 0.5 milliseconds over here. For 0.5 milliseconds it is going to be on, for 1.5 milliseconds it is going to be off. You will not be able to see that 1.5 milliseconds of this particular signal being off over here. By that time again what will happen, the LED will get charged again, then again it will discharge, then it will get charged over here. So you will be able to see the LED with the brightness of 25% over here. Okay, so that is why to our human eye this width will be looking long enough, but please remember this is 1.5 milliseconds over here. 1.5 milliseconds, okay, you will, by the time you think of snapping your finger, the time is gone. Okay, so that is 25%, this is 50% over here, and the next one is 75% over here. So 75% duty cycle means on time it is going to be 75% and 25% it is going to be off. On time it is 75, off time it is 25% over here. So most of the time it is on over here, so the LED is almost fully charged, almost 75%, and by the time it gets discharged over here, in that particular 0.5 millisecond time it will not be able to discharge fully. Again it is going to get recharged over here, so it is going to get charged again, and the charge is going to be it is going to last for a longer time. So that is why you will see that your LED is going to be 75% bright, and that is the condition when your analog bright is equal to 191 over here. So this is when your particular analog bright value is equal to 191. Okay. And lastly, we saw that when your 100% duty cycle is available, what does it mean? It means that a particular signal is having a DC signal over here, as in the case of your 0%. Here 100% means 100% of the time it is on over here, which means 100 minus 0 is 0%, it is off. So it is entirely a DC signal in which the LED is always, it is maximum bright. Okay, it is not always on, it is the maximum brightness over here, and that analog bright value is equal to 255 over here. So I hope you were able to understand from this duty cycle diagram over here that how the brightness of the LED or how the particular speed of DC motor can be varied just by changing these values of your percentages over here. Okay, and those percentages are with respect to your particular analog bright values, which vary from 0 to 255 only. So 8-bit representation, 2 power 8 is 256, and you can see that with that 8-bit representation you can vary the particular brightness of the particular LED or vary the speed of your DC motor. Okay, so if I want the device to be off, I give 0%. If I want the device to be on at the maximum speed or the maximum brightness, I give 100%. If I want to keep increasing, I will make sure that the value increases from 0, 5, 10, 20 all the way up to 255. After I reach 255, I decrement the values by a particular number, 255, 250, 245, 240, and so on all the way to 0. By doing this auto increment and auto decrement in my program, I'll be able to vary whatever I want, either the speed or my brightness accordingly. Okay, so I hope you understood the concept of PWM.